Hi, I am Jethro Gallardo, here to present to you the Unmanned Maritime Navigation System. I will do this by first introducing you to UNIT, Maritime Unmanned Navigation through Intelligence in Networks. It is a European Union project started September 2012 and was finished in August 2015. It has 8 partners, including 2 universities, with funding of 3.5 million euros, equivalent to $4.8 million. Its focus is to develop a concept for an unmanned merchant vessel and validate its effectiveness in a simulator setup. The concept involves, first, autonomous execution, the main operational mode. Here, ship system activities include following a predefined voyage plan and observing the environment while measuring ship condition. The shore control center monitors ship status. And so, communication activity via satellite bus is only periodic updates ship to shore. Autonomous control of handling of known events, such as interaction with other maritime vessels as illustrated here. Ships autonomously adapt voyage plan and involve shore control center if necessary. Shore control center ensures safe operations and acknowledges decisions if necessary. For this, communication is event-based data exchange. Lastly, remote control intervention in a special situation. Have the ship provide navigational data and control is overridden by shore control. Shore control center directly operates ship. For this, active communication is required via direct link or communication tunnel. In summary, the ship would have 4 modes, depending on the status of a certain problem: automatic, autonomous, remote, or fail-to-safe, in which the ship would just stop all its operations, except for preventing itself from drifting. Rolls-Royce is currently developing specific ship designs, including its software, frequently boasting its concepts to persuade the industry. As communication costs using satellite link is a very expensive service today, the shore operator also needs to keep track of not only available satellite links and bandwidth, but also communication costs. It is estimated that the cost can reach to $150,000 per month with today's prices, if real-time communication of all parameters were to be practiced. Why unmanned ships? The industry will most probably face a tightening labor market with the current shortages for officers. This is because of unappealing work environment. The context, however, is different for Filipinos and will be discussed more extensively later. The shipping industry has for decades reduced costs by cutting down on the size of the ship's crews. This in turn leads to stress, safety issues, and less attractive working conditions. Automation is a major driver in most industries, replacing manpower with machines. Because they have no need for crew facilities and systems like air conditioning, electricity, and sewage, the drone ships will theoretically be cheaper to operate. According to many reports, human error is involved in 65 to 96% of all accidents at sea. Removing humans from the direct control of the ship, accidents to some extent may be prevented. Real ships are a trend by reducing the speed of the typical container vessel by 30%, a 50% reduction in fuel consumption, and thereby also fuel costs and emissions can be achieved. This is more feasible with unmanned ships. The harsh conditions of seafaring do not dissuade Filipinos. 1 out of every 5 seamen in the world is Filipino. The Philippines is one of the primary sources of seamen in the global shipping and transport market. According to DOEA, the country is the main supplier of seamen since 1987. There are around 180,000 students who graduate from maritime schools every year. In 1996, it was estimated that there were more than 250,000 seafarers. In 2013, this number grew to 450,000. If unmanned ship system becomes successful, Filipinos will get left behind, together with the numerous maritime schools. An idea, however, local unmanned maritime navigation system using available but to be improved communication systems. UNIT proposes GSM, 3G, 4G, AIS, DDE as communication channels for the near coastal waters, and this may be used in the proposed local unmanned maritime navigation system. The country is an archipelago, and so only short travel distances involving transportation of cargo. Therefore, communications in extreme deep sea environment will not pose much of a problem. Aside from helping the economy, it will allow markets for maritime schools to train students in the unmanned maritime system to catch up and improve its notoriously low standards. Technology for this system may use it or not, either already in use or under development. Although there is strong resistance by the industry, for implementing the unmanned ship system because current maritime system is very well established. To show how ready we really are and that the industry is just being silly, afterward, one of the partners involved in Union developed the security system. It combines advanced stabilized knowledge and highly sensitive IR and digital video cameras integrated to a unique electronic chart system. The device is already in use and is mandatory on Norfolk-class vessels for use in the Norwegian continental shelf. These are ships that clean oil spills using secluded IR cameras capable of measuring temperature fluctuations to detect oil spills and successfully displaying them in the electronic chart system. Another notable project of aftermarket is TCMS, Tactical Collaboration and Management System, a standalone tactical tool for collaboration and information sharing between vessels, platforms, and land-based resources, involving safety critical operations at sea, utilizing and distributing data from all connected sensors. Another technology which may be used in the unmanned maritime navigation. Again, I am Jethro Gallardo on Unmanned Maritime Navigation System.